Here, like in this breakout session, we're going to discuss more about, like, from some kind of technical perspective, how we build out this event-driven like runtime for the fully autonomous agents. So a little bit about myself. My name is Xin Lu. I'm currently director of platform here at StreamNative, and I'm also a founding member for StreamNative. So we are mostly doing like we have done a lot of development works here at StreamNative, including the cloud platforms, the Pulsar engine, and now the newest like Agent Engine. And as a Pulsar committer, I worked on the Pulsar Functions and the I/O connectors previously. To begin with, today, like, we're going to discuss about three things, like how we view the agents nowadays, like the gaps and challenges to really bring it to the production environment and connect it with all the real-time data streaming. And then, like, how we build out our Agent Engine, like, from these observations and based on our principles we want to follow. And then, like, a summary from prototype to production autonomy. Without any further delay, so let's start it by the agents today, gaps and challenges section. So this is a quick overview of how the agents looks like nowadays. So there are a lot of different agent development SDKs, including OpenAI SDK, Agent Development ADK, LangChain, Llama Index, and I believe like just yesterday the Anthropic, they also announced the Cloud Code agent like SDKs. So there are really a lot of flavors, a lot of like different preferences when it comes to like building out your agent. And we also talked to some of our customers or some of other companies that was still building like vertical area agents. Most of the time, they would actually abandon all these agent development SDKs, just doing like pure Python or create their own SDKs. So very, very like fragmented SDKs environment at this time. But regardless, like most of the agents, they will probably be able to do some of these like following things, like with the LLM calling at its core as a foundation and accessing to different MCP tools and save some of the states for better like understanding or processing of the future requests, and then the session memories and context. So one of the common patterns we have been seeing is like agents is really easy to create some kind of prototype. Take myself, for example, the examples, demos we were just seeing, I was just using some kind of web coding and quickly wrap that up. So here like is another example that we get weather, which is a more like a trivial and even like simpler example that is the weather tool always tell you that it's sunny. So nothing fancy, and you can easily deploy it and start here to ask questions, pretend that to be a very smart agent, which can tell you the weather conditions of any city, although it will always be sunny. So like from this kind of easy prototype to the productions, we may think that, okay, I have the agents, then we can deploy that very easily, like just any other applications. But in the reality, it's like miles long away from actually it's production ready and to be able to handle the production traffics in the environment. So this is basically what we see with our users and the customers and partners. So what actually is the production gap here? So based on our discussion and our observations, like when the agents wants to be production autonomy agents ready, right? So there are a lot of like smaller like details you need to tackle with in order to make it fully ready, like what are data it can access and what kind of the tools that you can utilize to take actions. And how can we monitoring the agents, how it's working, and monitoring like logging and auditing, like see how it's working and what actions it has been taking and why it does that. And then, of course, like some of the CI/CD deployment automations and the security stuffs, like how we control it in order to prevent it from like accidentally delete everything in my systems, completely wipe out our databases, right? And also the LLM model selection and the evaluations of the agents, and how can we like do auto scaling if the traffic comes in and one day like our agents like it's really popular and everyone wants to use that. Our business keeps growing like 10x every week or month, right? And then prompt management. So these are all like technical engineering details in addition to these fancy agent ideas that we need to tackle in order to deploy that into a truly production-ready environment. So the challenges we have seen here is like if we do some kind of request to response and end-to-end point contact between like different point-to-point contact between like different agents, most of the time we'd end up like tightly coupled agents talking to each other. And there will be like messes if we want to make some kind of changes because our business requirement has been changed. It will be like very fragile. And also, if some of the agents get stuck or like there was a failure happening, like everyone like relying on it, communicating with it, will also be like blocked. So really, like there's no the decoupling of the agents and providing some kind of event brokers or like messaging buses as essential neural systems for all those agents to smoothly talking to each other, and providing such kind of a loosely coupled architecture would be ideal in our point of view. So I think everyone knows the saying that your AI is only as good as your data. So you have to have a high quality data in order to have a great model and in order to have AI to empowering your business use cases. And we kind of share the same view on the agent side, that is your agent is actually only as good as your infrastructure, assuming that you have already addressed the AI problems. So yeah, this is the same slides we used during the keynote speech. Basically, LLM and agents are evolving like from the basic LLM models capabilities with more like tech enhancement and technologies added, like fine-tune, RAG, and then MCP tools calling. So these are all like moving us toward to a more autonomous agents, which would be like smarter and more powerful, and will be able to handling like data and events in the real-time fashion. So we also discussed that this event-driven like foundation layer for the agents before in the keynote speech. So basically, what we want to do is actually decoupling the agents, like the point-to-point communication, and then ensuring that agents can actually have access to the real-time data and react to those real-time data and events quickly in a real-time fashion. And also, we want to have scalabilities. So in addition to the general like agent capabilities like perception, reasoning, and taking actions. So we believe that also like the reality is kind of event-driven. So real-time data access and responsiveness is needed by these agents. And we want to have these agents and the workflows to be loosely coupled, to collaborate together and easily adjusted based on the changing requirements of the business case. And also we need like scalability and the flexibilities. Probably last but not least, like multiplexing and replay all those data would be ideal if we are still exploring like what's the best form of agent and how we want to like utilize all the data available for the agents and tools. So as a summary, like we can see that there was some kind of production gap, and as well as some kind of requirement from the event-driven like autonomous agents here. And moving next, this is our like experiment, our step to answering all these questions and trying to make agent developers' life easier so that like the agent developers can solely focus on their own like core business use cases and don't need to deal with all these like infrastructure issues, like communication issues and scaling management issues for the agent. So to begin with, again, like these are some of the like principles we adopted since day one when we designed this engine from scratch. Basically, it has to be a streaming native runtime so that we can plug in like real-time data, whether in Kafka formats or Pulsar protocols, like easily. And we don't want to agent developers to like redo all the work just trying to like adding the streaming capabilities to the agents. We want to make sure that the agents has been fine-tuned, has been like properly engineered to work with the real-world data, can be easily like deployed into the streaming platform, that they don't need any change. They can immediately start to getting values from the streaming data. And flexible large language model selections is also I think some of the default requirement, because the more large language models are like are evolving like every weeks or months to having more like powerful models. I think Anthropic just launched their Cloud 4.5 or something, some newest models this week. And also like as part of the like agent's core capabilities, like it has to be able to call tools not only like the MCP tools that has been developed like by the broader ecosystem, but also these MCP tools, functions, and agents has been developed within the organizations. They should also be easily to be able to be utilized via the MCP protocol. And then like we want to have the persistent context, streaming memory, and state management for the agent so that it can be smarter over the time. And the last but not least is the enterprise grade platform. So we will get into some more details, like what do we mean by like enterprise grade platform. So to begin with, actually, we started from the functions. So for those of you not familiar with Pulsar, the Apache Pulsar project, Pulsar has this, since day one, it has this concept of Pulsar Functions, which is a very lightweight like processing unit that gets automatically connected to the Pulsar like topics. And the user only needs to focusing on the fx here on the left side of this graph, adding its own like processing logic. And the framework itself would actually help the functions, help users to connecting the functions to the streaming systems in the cloud, and providing the state management and the context facilities to achieve like all kinds of different business goals. So to some extent, we feel like agent is more like smart functions that equipped with all these like large language model capabilities, reasoning, and actions. So we kind of like based on what we have, what we are familiar with the functions, we actually like adjusted that and enhanced that based on the agent context we have here. So basically, the structure looks pretty similar. But in addition to the input and output like streaming data, we actually provide the access to LLM models for the agent, and then we also provide some very agent-specific tasks or capabilities that require via the LLM context. That including like the retrieval, basically you can search state, search external reg store, and search iceberg tables for some of the important data or knowledge-based data. And it has the ability to call different kind of MCP tools, that including the resource admin tools, functions tools, and external APC server like Zapier or something else. And it has the memories to remember, has the ability to remember important informations, and powered by all those states. So this is the architecture graph we have been showing on the keynote also. So if prettify it and look into that, this is how it looks like for a single agent, like running in the cloud. And some of the key key abstractions we added is like based on the functions abstraction we have, and we added the agent function, which it has the abstraction. It has the context-aware initialization via the agent context, and it has the like async process capabilities to handle data in an asynchronous way, and also it actually supports backward compatibility through process delegation. So with that, with the abstraction, with the architecture, and with the ideas and implementation, we actually also we move to the next topic is the protocols. So we want to have like the agent have the support for both Pulsar and the Kafka protocols. So to some extent, in our point of view, like Kafka is more suitable for data streaming, which you have a lot of data and large volumes of data, and people are more familiar with. So we want to make sure that those Kafka lovers can actually also utilize our platform to tackle the agent. And Pulsar, to some extent, it's event messaging systems. So it has like more flexible control for some of the patterns we just described on the keynote speech, like delayed message delivering and retry and rate limiting, those kind of stuff. So they are all having their own values for the agents, and we would like to support them more. And this next part is the bring your agents like a design philosophy. So one thing we do know is that everyone in the agent development area is using Python. So we want to have the Pythonic support for our agent engine instead of like asking user to rewrite your agent like using Java or something else. And the other thing we don't know is like which runtime or which like agent SDK would be the winner in the following, or is there even possibility to have a winner? Like people would like to stay fragmented and using whatever tools to their like taste of flavor. So these are just a list of different agents. And no matter like which agent SDK they want to use, what we want to achieve is like once you have an agent developed and ready to deployment, all you need to do is like register your agent as a root agent, so that like the system can know the entry point of this agent, and then like start it to run it in the cloud environment. So so we also would like to have the flexible LLM model selections, whether that's Google Gemini or OpenAI like GPT. So things like the project called Light LLM, it actually provides like 100 plus like LLM models. So models is like whatever models you want to use, whether for higher, stronger performance or lower cost, anything, you have the flexibility to do that. And probably like one of the key things is actually comes to the security side, like how can we access models securely? And since we are like infrastructure builders and we have tackled these problems when people want to use functions in the cloud security to access the AWS and GCP services. So we provide those kind of secret integrations for users to use. And then MCP is actually another very interesting part. So I think in the beginning of this year, we announced the StreamNative MCP server, which is used to, which can be utilized to help like the streaming like cluster manager admins to manipulate their clusters for whether that's a Kafka or like Pulsar clusters. And here, like we are hosting, actually inside our cloud, inside the cloud environment, we're hosting the MCP protocol server with all these like default tools and the StreamNative tools available, as we have been seeing in the keynote speech. And for the security and authorizations, that's actually another like very important part. We implemented the OAuth 2. I think it's OAuth 2.1, as well as some of the key authors behavior to make sure that the agents can access the MCP service like in a very secure way. And also our engine, like since it can call other tools, it actually reuses the agent credentials when access to the remote StreamNative MCP servers to ensuring that there's no like permission leak or escalations for the agents to do something kind of unexpected. So one of the like a fun thing and an interesting part is like you can actually do like feature selections and make some of the tools be submit that in a read-only mode to make sure that your agent can access the MCP tool, access the selected MCP tool, and in a read-only mode, so that it won't like taking like create damages for your systems. We also like expose functions and agents as MCP tools with metadata available. So if you have seen the demos in the keynote speech, you will see that the agent we have been submitted to the engine, as long as it's properly registered, providing those like MCP name and MCP descriptions, metadata information, other agents can actually discover it and utilize it in the following. So we kind of like bridges between the StreamNative cloud clusters and agents and external MCP clients all the way around. So this is our like thinking and design for the MCP part to enabling the autonomous agents. And then like it comes to the persistent context and streaming memory and state. So we extended, actually like we extended the Pulsar Functions context with agent-specific capabilities, which includes like getting the message admin, getting message client, and getting tools and getting session mode. So the tool integration is like basically a unified interface for both Google ADK and OpenAI tools. But that's not limited to that. These are just like a very initial first implementations we have done. And for the MCP like support, we added the SSE and HTTP streamable like with notification support. This basically enables us to dynamically update all the like agents in the systems to be aware of some of the newer capabilities available, newer agents or functions submitted to the cloud to be able to calling them, which like based on our observation, like the current existing like agent SDKs don't support that yet. But so we did on our own. And as the session management, there's like 3 different modes, like shared session per message and session per user, so that your agent can actually better manage the sessions better and create a like more meaningful result for your user for your request. So for the state backend, if you have checked the keynote speech demo, we actually have the ability to remember like what are the questions the user asks and what are some of the like state has been previously saved cached in the systems. So this is actually based on the project we call Oksha. We use Oksha as the base state backend for the session and the state persistency. So basically, if you happen to like read the URSA paper, you will know that Oksha is our distributed like metadata store to some extent, and we are reusing these Oksha services for the agent-like state in our engine case. So last but not, I think the next thing is like we have been like viewing like single agents working in production, right? Actually, like the beauty or the power of the Agent Engine really like lies in when it comes to you have a lot of agents. Like Reynolds said, like you may in the future, like every organization may have thousands of agents, right? So you can actually create a mesh of workflows and agents to collaborate together to accomplish some of the very like complex tasks. And we will see that in this in a demo here, like we specifically created, you will see that several agents are collaborating together, calling MCP tools and taking actions towards some kind of the real world like cluster and services just to try to resolve that. And yeah, and also it done to like completely rewrite and revolution like your existing workflows over the night. You have the flexibility to choose like which functions or which part of the existing workflows might need to be made smarter and can be replaced with agents. So these are all possible with our engine. And yeah, the enterprise-grade platform is a lot of like details here to tackle with in order to make it truly like enterprise ready. But we roughly categorize them into three big categories and adding those items. Like for the deployment, it has to be like serverless and the Kubernetes native. We don't want our users to manage another cluster just to run these agents. And it also has the multi-cloud support. So you won't be like locked by those hyperscaler vendors like AWS, GCP, or Azure. And in terms of managing those agents, although like in the demo I have been showing that we can submit the agents like via CLIs or like reviewing like those agents via UIs. Actually, like our plan is to adding more like IAC tools like Terraform or like Kubernetes operator support, so that like it can, when you have a large fleet of agents, those can be managed very easily. We would be having like a vertical auto scaling and horizontal auto scalings for these agents automatically, so that you don't need to be worried about like the backlogs, failure handling, all those kind of stuff, and also of course the automatic failure retry. So for the security, I think security is one of the very universal topics across the whole like components or life cycles of the system. So we have been tackling that with the RBACs, with all those kind of auth controls, as well as like monitoring, logging, and auditing. So really, a very quick overview, like these are the like capabilities we built into our Agent Engine in order to make sure that when the autonomous agents like days comes, like we already have the answer to that, and our users can be really kind of ahead of the time of the AI revolutions and agent like development. So with that said, I think I will share with you another very interesting demo, which is developed with Google Agent Google ADK and more complex tasks. So bear with me. So here, like we are having some kind of topics, Pulsar topics, which basically has some kind of backlogs sitting in the topic. As you can see, like this one is around 200. So and another partition has another like about 200 backlogs. So normally, if your application is continuously processing the data, you won't have those kind of backlogs. Can you see that? Okay. Sure. Side. Or sorry about that. I will probably just pause and show you some of the keyframes. So basically, the setup is like we have topics partitions with backlogs, and the system is not processing. Something is wrong. We need to handle that. And instead of like manual interventions, we actually developed a set of like agents to do that. So the first agent we have been doing is the what we call is the intake enrichment agent, which would actually receive some of the alerts or like manual like triggering to ask it to take actions, do some kind of initial investigations and enhancement of the alerts. So basically, it's a lot of like promptings, a lot of prompts like to instruct what the agent should be able to do. And then like we have another agent called investigation planning agent that it's like based on the promptings and based on the input from the enrichment agent, you will actually do more investigations and even search the knowledge base from some kind of PG database to do that. And then like we will have the RCA, the root cause analysis agent, which based on the information they provided, it will come up with a root cause and come up with some kind of the action plans to take in order to fix the problems. So we can then we can then package all those. Oh, by the way, these are all the agents that developed natively using Google ADK. So we can package all of them and then preparing the configuration YAML configuration files to instruct how the system should be running it. So again, we will be registering this intake enrichment agent as an MCP tool in the systems. And in addition to that, probably one of the interesting things here is the agent tools configurations. So we not only provide the MCP streamable servers, but also specifically call out that what other tools should be included where to be available with this agent. And these are some of the input and output and where the agent file lives and these kind of configurations. And then once we submit that with, as usual, it will be running, up and running. And the same for the investigation planning agent. The same structure, like always open secrets and all these MCP settings. And we can also launch it. I think so on and so forth. I'm just gonna skip a little bit. So here, what we are doing is instead of I'm calling the triggering functions in the keynote demo, we are right now here we're just using some kind of Pulsar client to publish an actual event or messages into the topics where the intake agent was listening to ask it for saying that there's a subscription backlogs for the partition topic and help us investigating that. So this message has been successfully published to the destination topic, and then we can also consume from the output topics for this agent. We can see that it's actually based on the prompt, based on the tools we have enabling that, it's actually generated a more detailed enrichment of this message, what are the backlogs on each partitions and some of the key metrics it's available for the user and actually for the next agent. So then we can go to the things these agents are connected via different topics. One's output would be the other one's input. What we're doing, the whole pipeline has been triggered once the first message, initial investigation message has been sent out. So we're just checking what's actually inside this whole pipeline each agent was generating. So here this second agent was creating a summary for the simpletons and then recommending what are the actual what kind of tools you can utilize just to help you solve this kind of issue. And yeah, then the next agent would actually generate an RCA report and providing the most confident level of actions it wants to take. So let me actually go through a little faster. So and also like generate RCA for that. So once we have all these like running, and we will be able to see that the final agent would actually calling the tools to taking actions to restart, create rescale the stop the functions and ask it to start to process the kind of the result. So this all happens like then like we can list the functions, which we would be able to see the missing like add XM FM functions, and we can also check its running status to see that the action after some round of like investigations and actions, this function has actually been started successfully to process all the like backlog data here. And then we can check the stats on those like different like topic partitions, which we see in the beginning have like backlogs. Yeah, actually have all these backlogs be cleared up. Yeah. So yeah, I think that's a kind of brief review of this demo, which is more complex than the one we see in the keynote. But you get ideas. So it was developed with some open like public available agent SDK, and it can be deployed easily onto the cloud platform, and then we can utilize chaining the streaming data to the agents so that they can take actions, utilize MCP tools, and querying the knowledge base to formalize some kind of plan and taking actual actions to fix the problems for the system admin. So as a quick summary for this prototype to production autonomy, like we kind of like build all these feature functionalities here, just to make sure that it will be easier for the agent developers to hurrying the like streaming challenges and to get rid of all those like infrastructure complexities. And probably in the next, we're going to add more like agent framework support, because like new agent framework support has been like launching like continuously, and we want to provide agent mesh and plan support and some of the IEC enhancements so that people can really like enjoy like deploying and managing all those agents very easily. So this is a small like Orca pack. So the four of us, like since the inception of the ideas and develop a prototype and finally bring it to the cloud environment, thanks to all the team members who work on this. And yeah, I think that's probably all for it. Thank you for attending this session. We are kind of just probably on time. Yeah. In case you have any questions, we can discuss and yeah, offline.